So here's what we're going to cover. TK, we're going to leave moles for a second. TK, we're going to move towards this. Now, you got redox reactions. And this thing with redox reactions is, does anyone know what it means? I mean, what is reduction and oxidation? What's the definition?
So oxidation is
Reduction, loss of oxygen.
Okay. So reduction is 1 by 1. It's gain of electrons, and remember, it's basically gain of electrons. That's it. The rest is just I mean, it's basically gain of electrons. Technically, like if anyone is going to ask you what reduction is, it's a gain of electrons. And when something gains electrons, you can talk about other things. Like the other stuff is like techniques of figuring out whether reduction is happening or not happening. So the loss of oxygen is not a definition of reduction. It's just of oxygen atoms actually, and a gain of hydrogen atoms. And whenever something gains electrons, its oxidation state decreases. So it's a decrease of oxidation state. I'm just going to call it O.S right at the moment. And oxidation is exactly the opposite. So oxidation is going to be, it's going to be the opposite. So if we talk about oxidation, it's going to be, I mean, let me rub this off. All I need to change is these words: loss, gain, decrease. So what is oxidation? Oxidation is a loss of electrons, and it's a gain of oxygen, and it's a loss of hydrogen atom, and it's an increase of oxidation state. So that is exactly the opposite of what reduction is. But remember, basically all these things are just kind of, they tell you whether it's whether there's a gain of electron happening, there's a loss of electron happening. So these things kind of explain that, but mainly the definition is gain of electrons, loss of electrons. TK, remember that. Never answer that reduction is a loss of oxygen or is it a gain of hydrogen. Don't ever use those words when you're describing reduction. Now, the other thing is about the charges. TK, we need to figure out the charges. Like, remember this, atoms can have multiple charges. You can have +3, you can have +4. You can have not +3, I'm going to decrease. So you can have +2, you can have +1. It can have 0 charge as well. If you start decreasing the charge, it can be -1, -2, and -3. So atoms can have all sorts of charges, and the charges can increase, they can also decrease. So if the charge is increasing, what is happening? Is it oxidation or is it reduction? I mean, we just wrote this down that whenever
oxidation,
TK, it's going to be oxidation. Increase of oxidation state is oxidation. That means they're losing electrons. There's a loss of electrons happening, and this is oxidation. So whenever something loses electrons, it becomes more positive, and vice versa. If something gains electrons, it becomes more negative. So that means this one is a gain of electrons. And this one is going to be called reduction. So think of this in this term. Think of this as, I mean, this is very obvious. I think everyone agrees with this. Like if you lose electrons, you become more positive. If you gain electrons, you become more negative, right? So, so what is happening over here? Can anyone quickly tell me if Mn changes from +7 and it changes to +2? What's going on? Oxidation or reduction?
reduction. Reduction.
Okay, that's reduction. So whenever you're going down, okay, whenever the charge is decreasing, that's a gain of electrons. And how many electrons are gained?
5.
Okay, that's going to be 5. 5 electrons are going to be gained over here. Okay, so it's going to be 5. And so 5 electrons are going to be gained. Just hold on a second. So 5 electrons are going to be gained. And so I'm just going to do things like this. For example, if you're going from Cl -1 to Cl +1, what's happening here?
Oxidation. Oxidation.
Okay, that is oxidation. You're going from -1 to +1. Okay, you're going up. So when you're going up, when the charge is increasing, that's oxidation. And how many electrons are lost?
Two.
Okay, so the 2 electrons being lost. So just remember that. I mean, you have to mentally think of this. Oxidation, I mean, this should be on your fingertips. Like it should be, I mean, you don't have to think about this. Whenever there's a loss of electrons, oxidation happens, the charge goes up. Whenever there's a gain of electrons, the reduction happens and the charge goes down. So, so this should come, I mean, you shouldn't be confused with this. So SN4 plus to SN2 plus, what's happening? Gain of electrons, loss of electrons.
Loss of electron.
Yeah, are you sure?
No, gain, sorry.
Okay. So just be careful. I mean, it looks very easy, but people make mistakes with this. Okay, so you have to be very careful. You're going from plus, you're going down. So so remember, reduction, the word reduction is kind of self-explanatory. So if the charge is getting reduced, it goes from 4 plus to 2 plus. That's a gain of electrons. That is reduction. Okay. So I think the word reduction has the hint. So whenever the charge is getting reduced, it decreases. That is a gain of electrons, and so on. So let's do a few more. We can have so what is happening? So what is happening here in this case?
Loss of electron.
Loss of electrons.
Yes, sir.
What's happening to the charge? Is it decreasing, reducing, or is it increasing?
Reduction. Gain of electron.
It's reduction. It's a gain of electrons. You're going from 3 plus to 1 plus. You're basically decreasing. So it's a gain of electrons and gain of 2 electrons. You go from 3 plus to 1 plus. So look at the charge. If it's reducing, then it's a gain of electrons. Let's do a few more. Like if you've got oxygen, which is -3, and now you've got oxygen, which is 1 plus. What happened here? Oxidation or reduction?
Reduction.
The reduction, you're going down. The charge should decrease. You're going from -3 to, you're going up.
Oxidation.
Okay, so that is oxidation, and that's a loss of 4 electrons. Is this clear? You can just be very careful with this. Like just try and understand it this way, that if the charge is increasing, that's a loss of electrons. If it's decreasing, it's a gain of electrons. So I'll do one more. That's F -1 to F +4. What went on over here? Gain or loss?
Loss.
Okay, so that is oxidation. Your charge is increasing, it's going up, you're losing electrons. How many electrons are lost? I mean, that is basically the difference between the charges. So how many electrons are lost?
4.
The -1 to +4. Well, what's the difference between -1 to +4? That's
5.
okay, that is 5. So 5 electrons are lost. Okay, I just feel we need to practice this a bit more. Just let's do 2 more questions. Sulfur -2 to sulfur 0. क्या हुआ यहाँ पे? What happened?
Oxidation.
So the charge is increasing. That's an increase in oxidation states. -2 to 0. So you're moving up. -2 to 0. You're moving up. That's a loss of electrons and loss of 2 electrons. So what happened? What's going on here? I've got Fe4 plus, and I've got Fe1 plus.
Reduction.
Okay, that is reduction. The charge is getting reduced. It's gaining electron. It's gaining exactly
3 electrons.
3 electrons. So just remember this. TK, we'll continue this. TK, because oxidation reduction is all about the oxidation state, that the charges are decreasing or the charges are increasing. So that is all what oxidation reduction is all about. So you have to figure out the charge on the element. So over here you can kind of state what's going on, oxidation or reduction. Charge increases, oxidation. That is also increasing, that's oxidation. That's also increasing. -2 to 0 is increasing, that is oxidation. If it decreases, that's reduction. 4 plus to 1 plus, that is reduction. 3 plus to 1 plus, that's reducing, that's reduction. 4 plus to 2 plus, that's also the charge reducing, that's reduction. -1 to +1, that's increasing, that's oxidation. And this is also reduction. +7 to +2, the charge is reducing, so that's reduction. Now, the thing is that now the next question is, how do you figure out how do you figure out the charges on these elements? 1 second. So how do you in the first place figure this out? Like what are oxidation states? Why do you? So what are oxidation states? And how do you assign elements charges? So what are oxidation states and how do you figure out, or how do you assign elements charges? So it's not an issue in ionic compounds, not an issue. Okay, ionic compounds, whenever you have an ionic compound, and there's another question, which is like, what is the difference between charge and oxidation state? Like, I mean, they're kind of the same thing, but why do you call these charges oxidation states? And like, I mean, there's a very tiny difference between charges and oxidation state. So we're going to explain that as well. So ionic compounds, in ionic compounds, the charge is the oxidation state. No issues there. So it is the oxidation state in ionic compounds. For example, you've got NaCl. Now in NaCl, Na is +1 and Cl is -1. Okay, so in ionic compounds, Na is +1, Cl is -1. So the charge is the oxidation state. There's no issue there. No problems there. The charge is going to be the oxidation state. Group 1 is always +1. Group 2, whenever they form compounds, they're +2. Group 3 is +3, and so on. So that's not an issue there. The problem comes if I have a covalent molecule, like I have a covalent molecule of CH4. Now a covalent molecule is like this. It doesn't have a charge. Okay, so for example, I've got a carbon atom, and I've got these 4 hydrogen atoms, and let's make 4 of them. So I've got these 4 hydrogen atoms. So these are my 4 hydrogen atoms, and carbon needs 4 electrons. So let's do a bit of covalent bonding. So carbon has these 4 electrons, and its outer shell is not complete, so it needs 4 more electrons. So what it would do is it's going to take this hydrogen atom and pull it and attract it to itself and bond with it. And that would be a covalent bond. So no one ended up gaining or losing electrons. They ended up forming a covalent bond. The H atom also has an electron. So carbon is going to try and pull that electron, and it will pull that electron and start sharing electrons with it. And so carbon gets a second electron. You've got another hydrogen atom, and this other hydrogen atom has 1 electron, and carbon pulls that hydrogen atom, so carbon gets its 3rd electron. And you've got this 4th hydrogen atom, and this 4th hydrogen atom, carbon pulls that electron and bonds with it. So that's your CH4 molecule, right? Pretty much you kind of know what covalent bonding is. We're not going to discuss that in detail at the moment, but this is what a covalent molecule is. No one gains or loses electrons. Like apparently no one gains or loses electrons. So the point is, why are we giving them charges? Like in oxidation states, if you remember O-levels oxidation state, and even if you don't remember O-levels oxidation state is, they don't have any charges. Okay, everyone will agree with this. Like hydrogen did not lose any electrons. Carbon did not gain. I mean, they just ended up sharing electrons, right? Is this point clear that then no one is gaining? Afin, is this clear, Amit?
Yes, sir.
So the point is no one gains or loses electrons. But when you talk about oxidation states, we assign H as +1. And we say that carbon over here is -4. I mean, we give it a charge, which isn't even there. Okay, so first thing is, I mean, the very first thing is, okay, just a second. So the very first thing is, ionic compounds, you've got no issues. The charges are the oxidation states. But what are these charges doing in this covalent molecule? Where did they come from? That's a big issue. Like why am I giving carbon -4 and why is hydrogen +1? Because it should not be +1 and this should not be -4. So we're gonna cover this story now. Okay, ionic compounds, no issue. They already have charges, right? Why are you assigning charges to these covalent molecules? Where are they coming from? That's the big issue. So we're going to talk about that issue now. And we're going to discuss covalent molecules in a bit more detail. I'm going to talk about ionic and covalent in a slightly more detail. And then we're going to talk about, like, why do we give CH4 charges? Why is carbon having charges? Why is H having charges when they're not even there? So the thing is, let's do some backstory of why are some elements ionic and why are some elements covalent. So you have a periodic table, and in the periodic table, you've got metals on the left side, and you've got non-metals which are on the right side. Remember, we're trying to understand oxidation states over here. So you've got metals over here and non-metals on the right side. Now, there's one major difference between metals and non-metals, and that is that metals like to gain electrons. So you like to lose electrons, actually. They like to form positive ions. And you've got non-metals over here. They like to gain electrons. They're always forming, they're always forming negative ions. So they like to gain electrons and they like to form negative ions. Okay, this is something that you'll all agree with me. Okay, you've always seen Cl forming -1 ions. You've always seen Na forming +1 ions. Okay, these metals like to lose electrons. These metals over here, they like to gain electrons. So there's a thing that's going on over here. I mean, why do they like to lose electrons? Why do they like to gain electrons? So there's a thing that's happening in the periodic table, which wasn't really discussed in O levels. And that thing is, there's a thing called electronegativity. Now, electronegativity is the tendency for an atom to actually gain electrons. And that electronegativity, it increases on the right side. When you move to the right of the periodic table, the elements become more electronegative. And it also increases when you move to the top. Like smaller atoms are more electronegative. So it increases. So the question is, the bigger question is, why does it increase? Like, why do elements become more electronegative when you move to the right? And it's a gradual change. It's not like an abrupt change. You don't have metals and there's a borderline somewhere in the middle, and on the right side, they're non-metals. The change from metals like to lose electrons to non-metals like to gain electrons, it's a gradual change. So I'm going to rub this off, and we're going to think of elements in terms of electronegativity. The elements in this corner are the ones that are very electronegative. They really like to gain electrons compared to all the other elements. Okay? So when you move to this corner, the elements really like to gain electrons. So the first question is, why do they like to gain electrons? Like, what's wrong with these? What's happening with these elements, and what's happening with these elements that they don't like to gain electrons? So the thing is, like, if you look at the periodic table, and let me open a periodic table. Okay, let's open the O levels periodic table. So here's my O levels periodic table. First thing is, why are electrons attracted to atoms in the first place? Electrons are attracted to atoms because they've got protons in them. The nucleus has positive charge. It's got protons. Like fluorine has 9 protons. Lithium over here has 3 protons. So when you move to the right, what's happening? Look at the protons. It's 3, then 4, then you've got 5, 6, 7, and 8, and 9, and 10. So check any row. The number of protons are increasing. Like potassium has 19 protons, and bromine over here has 35 protons. So the nucleus of bromine is really positively charged. So it's going to be attracting its electrons very strongly. So this is what's happening. This is the first thing that's happening. Like the protons increase. For example, you've got Na over here. It's got 11 protons. And you got Cl on the other extreme. It's got 17 protons. So when you move to the right, what happens is that the nucleus becomes more and more positively charged. So it's got more protons. You can remember this concept would be used in a lot of places when you study AS chemical bonding and AS atomic structure. So when you move to the right, the protons continuously gradually increase. So you're going to have a more positive nucleus. And when you have a more positive nucleus, there's going to be more attraction for electrons. So there's going to be more attraction for electrons. So that kind of makes sense. Like the electronegativity increases to the right because the elements that are on the right have more protons. So there's going to be a lot more attraction for electrons. Cl is going to attract electrons with a lot more strength. Na just has 11 protons, so it's not going to attract electrons that strongly. Look at the previous row, 3 protons. Lithium just has 3 protons. Fluorine on the other extreme has got 9 protons. So fluorine will attract its electrons with a lot more strength. So fluorine is going to have, because it's got a more positive nucleus. I mean, I can just draw that nucleus over here. Let's say this is just 3 protons, just to make it clear. And fluorine on the other end, I mean, this is fluorine's nucleus. The nucleus has a charge of +9. So it's pretty obvious who's going to attract electrons more. Like +3 is not going to attract electrons that strongly compared to a nucleus that has a charge of +9. Is the first point clear, everyone? Clear है ये? Ospa, is this clear? Mahad? Izan, Mahad?
Yes, sir.
Ahmed, is this clear? Any questions?
Yes, sir.
Yes.
Okay, so that's the first thing. TK, you've got when you move to the right, you get more protons. So naturally, there's going to be a lot more attraction for electrons. The other thing, what's happening up the group? Why do elements they become more electronegative? Why does their tendency to gain electrons increases? TK, I mean, it makes sense when you move to the right. You got more protons. The nucleus is more positively charged, so obviously there's going to be a higher attraction for electrons. So what happens up the group? What happens up the group is that the atom becomes smaller. So I'm just going to draw fluorine and chlorine, and let's say I'll have what comes after that, I think bromine. And then you've got iodine, right? So let's just copy paste a few atoms. Like I'm just going to quickly, so I've got a fluorine atom. So I'm just going to copy a, let's take this fluorine atom. I'm going to copy this. Where's this one? So here's a fluorine atom. Okay, so what's happening up the group when you move upwards in the periodic table? The other one, let's take fluorine atom. This one. So here's my chlorine atom, right? And maybe there's a bromine atom, so let's bring that in just for clarity. I mean, you can see what's going on. The atom size is becoming, it's becoming bigger. So here's a bromine atom. So kind of pretty evident. Now, why does bromine, I mean, why is bromine not, I mean, fluorine attracts electrons a lot strongly, right? There's a thing called shielding. So you've got an electron, and I'm keeping that electron very close to fluorine. So you can see the electron. The electron is going to be attracted by the nucleus of fluorine. And you've got an electron over here in the case of bromine. And the electron is going to be attracted by the nucleus of bromine. So why does fluorine attract the electron more strongly? Because the nucleus of fluorine is a lot more exposed. It's got less shells. So it can see, I mean, the positive nucleus over here, remember the nucleus is positively charged. So let's put a plus sign over there. So you got a positive nucleus, and it will be attracting the electron very strongly because there's not a lot of things coming in the way. What's the problem with bromine now? Like bromine is positive as well. But when an electron comes, there are too many electrons already around bromine. And what do electrons do? Electrons will repel this other electron that's coming in. Okay, let me just rewrite this. So when an electron comes, the nucleus is already shielded. It's surrounded by a lot of electrons already. So its ability to attract an electron that's much further away would diminish. It would be lesser because the other electrons are going to come in the way. They're going to block this electron. They're actually going to repel this electron. They're not going to allow it to come close to this nucleus. Do you get this point? Is this clear? Siddha, is this clear? Mahad is
Yes.
on. So this is something that happens. That when you have bigger atoms like down the group, whenever you move down the group in the periodic table, you got bigger and bigger atoms, right? Bigger atoms already have too many electrons around them. I mean, they're surrounded by electrons. Like if I take an iodine atom, that would be even, I mean, the situation over there would be even worse. Like if I take an iodine atom, look at the iodine atom, it's surrounded by too many electrons. Okay, the iodine atom would be even bigger compared to I mean, it's going to be even bigger compared to and it's going to have even more electrons. So that's an iodine atom. Too many electrons. So it would even be difficult for iodine to even control its own electrons. Like the nucleus of iodine is already busy. It's got too many electrons. It's got 53 electrons. So it like 2, 8, 18, 18, and 7. So that's a lot of electrons around it. So it would be very difficult for the nucleus to attract an extra electron. Okay? So remember, you in O levels you did study this, that the reactivity of nonmetals increases up the group. This is the reason why, because you've got, when you get bigger atoms, they already have too many electrons. So they can't really, it would be very difficult for the nucleus to attract more electrons, because those electrons are going to be repelled by the 50 or so electrons that are already there. So for fluorine, it would be very easy. The nucleus would be really exposed, and the electron can easily, I mean, the force of attraction would be pretty strong because the electron would be very close to it, and there are not a lot of electrons that would be coming in the way. So remember this, smaller atoms, this is what I'm going to write over here, that smaller atoms are less shielded. They have less shielded nuclei, or the nuclei is not surrounded by a lot of electrons. So it's easier for them to attract more electrons. So there's going to be stronger attraction for electrons. So two factors are present, which is why the elements in this corner over here, this is your electronegative corner. This is the one where elements really like to gain electrons. What happens when you move towards the right? The electronegativity increases. Why does it increase? Because you've got more protons. When you move to the right, the number of protons keep on increasing. You've got 3 protons, you've got 9 protons. So obviously elements having 9 protons are going to be attracting electrons with a lot more strength. So the electronegativity, or the tendency to attract electrons, increases to the right. And it also increases up the group because smaller atoms are less shielded, and therefore they have stronger attraction for electrons that are coming from the outside. So this is your electronegative corner. The other one is your electropositive. These ones are not the ones. So as you move further away from this corner over here, the elements become less and less electronegative. Okay, so this is your corner, which is, so who's the most electronegative element in the entire periodic table? That's fluorine. So is this clear? I mean, the concept of electronegativity, is this clear? I mean, the first concept. Oswa, is this clear, Siddha? Maha, Dizan? Em, is clear?
Yes.
So there's there's a Pauling scale which actually gives you electronegativity. So oxidation state wali baat jo na, we'll try and complete that tomorrow. The next classes we just did electronegativity over here. So there's actually a table which is not I mean, you just need to know the trend of electronegativity. So there's a, I mean this one is pretty, I mean, this is 3-dimensional. I'll just copy this image and we can delete all of these. So this is kind of a 3-dimensional visualization of which elements are really electronegative. So you can kind of see that elements that are right in the corner, you're ignoring noble gases because noble gases, they can't really gain electrons because they're already full. So the elements in the corner like fluorine, oxygen, nitrogen, I mean, the top corner, this one over here, that's very electronegative. So that, and as you move further away from that corner, the elements become less and less electronegative. So I gave you the concept of metals and non-metals, right? So remember, it's not, the transition is a gradual transition. The elements on the left are metals, they like to lose electrons, and the elements on the right are non-metals, and they like to gain electrons. But the transition from a metal to non-metal is not like, there's no dividing line like these are metals and these are non-metals. You've got lots of metalloids in the middle as well. The idea of a metal was that it likes to lose electrons. The idea of a non-metal was that it likes to gain electrons. But remember, it's a relative idea. Like, it depends on the electronegativity. Who likes to gain electrons, who likes to lose electrons. It's always comparative. So we're going to discuss that later on, and we're going to talk about ionic and covalent by looking at this now. Okay. So any questions about this? Is this all clear? I mean, the first part we just did, I mean, ignore the oxidation state. We just did the electronegativity part.
Sir,
Yes.
sir, electronegativity की definition बताइएगा sir दोबारा.
And उसकी बस definition, it's the tendency for an atom to gain a shared pair of electrons. Or just the general definition is that the tendency of an atom to gain electrons. No one is going to ask you about the definition in CIE about this, TK, but you just need to know the concept. To gain a shared pair of electrons, or simply the tendency for an atom to gain electrons. Is this clear?
Yes, sir.
So let's continue tomorrow, and I'm going to link this electronegativity thing with ionic and covalent bonding now, TK. And from that, we're going to discuss why do we get oxidation states? What does +1 mean? What does -1 mean, TK? So let's continue tomorrow then. Okay, everyone. Take care, Allah Hafiz.
सर
हाँ जी,
सर आप इस बोर्ड की लिंक शेयर कर सकते हैं.
ये मैं कर रहा हूँ अभी कर.
ओके ओके सर.
ठीक है.
सर पहले वाला माइक्रो पे था, ये हाइड्रो पे है.
हाँ, ये मैं हाइड्रो पे आ गया हूँ, स्लो हो गया पता नहीं माइरो फॉर सम रीजन. ठीक है.
ओके सर, ठीक है. अल्लाह हाफिज. थैंक यू.
अल्लाह हाफिज. अल्लाह हाफिज.